My name's Kenton Lawler. I'm CEO of Ames International. We're a structural engineering company. We specialize in fiber reinforced polymers.
My name's Chris Berry. I invest in small businesses and assist in running them.
My name is William Williams. I'm a research engineer with Texas A&M Transportation Institute. I do designing and crash testing bridge rails.
Life Rail System is a product we developed that is a composite of 3/16 stainless steel tube and fiber reinforced polymer.
It's a double entendre, I think. First of all, because this railing system, it saves lives. And then secondarily, has a much longer life cycle than the steel system.
All of our testing was done at Texas A&M. The system has been MASH level TL4 tested all the way up to 75 miles per hour, which is well outside the boundaries of MASH level TL4 testing. That's a criteria for pickups, compact cars, and box trucks.
I'm one of the experts in the country on bridge railing, bridge rail analysis. I would say that's my bread and butter. We're one of the premier crash houses in the country, if not the world.
When the vehicles impact into the rail, they measure all of the forces, the lateral and longitudinal ride down loads, occupant impact velocities, roll angles, pitch, yaw, roll. They tow these vehicles into the rail. For example, the car is towed in at 25 degrees at 63 miles per hour, as is the pickup. And the box truck, which is 20,000 pounds, is towed in at 15 degrees at 53 miles per hour, I believe it is.
Crash testing is really the proof. It's all about strength and performance.
In addition to that, we were requested by GNOEC to crash test up to 75 miles per hour.
A lot of people can get the strength right, but it's the performance of how the vehicle is going to engage the rail.
And from there, they compare it to the MASH standard to see if you're outside of the scope or the boundaries set by MASH TL4. And if you're outside, then you fail the test. Well, we passed it.
You know, we applied a lot of load over a small area to the FRP to see if it was going to just crush all the way through it. And it performed well. It gave us a level of confidence that we really needed to feel before we proceeded further.
But here's a product that was load tested and it came out with flying colors.
The impact on occupants is less, as judged by the objective results from the testing that's been done by TTI.
It does have mechanical properties that are different than steel. It's not as stiff as steel. So it is more flexible. It has some restoring characteristics that it exhibited those characteristics, I think, in a favorable way in terms of how the vehicle performed.
And that results from the fact that the fiberglass gives more than the steel does. Because the steel is rigid, it kicks the vehicle faster, and the occupant has a bigger shock. So there's a 10 to 15% less impact on the occupant with the Life Rail system.
In terms of performance, the major advantage of the FRP system is that it does not corrode. It does perform, and it does meet the objective of MASH testing. That we've proven that.
In order to document that and to prove it, we have gone out and hired Dr. Binder Singh, who is a corrosion PhD. He works for all of the major oil companies and has for the last 35 years.
My name is Bhupinder Singh. I go by Binder for short, and I am a corrosion specialist. The Achilles heel for steel has always been corrosion.
But that's only part of the story. The whole story is, what does it look like in 60 years? Well, we know what the steel's going to look like in 60 years. You can drive around our country and see it everywhere. It's rust, and it's a high demand on maintenance and maintenance costs. What does that mean to the average motorist? Well, those are tax dollars.
The life cycle performance is so good that you're going to save money over the life cycle.
In fact, in this case, Ames International is giving a 60-year warranty on the product. That's unheard of.
Well, yeah, no one's going to give a 60-year warranty on galvanized steel. It won't last. They know it won't last.
And one of the ways that we revolutionize the industry is that the Life Rail system lasts 3 to 4 times as long as the steel system in the same application.
If you've got a product that lasts 3 times longer than steel, wouldn't you want to use it?
So if you look at a 100-year life cycle for a steel application versus the life rail application, with steel, you're going to have to replace it in a bridge rail context 4 or 5 times, including maintaining it. With life rail, you're not going to have to replace it at all.
FRP is a really strong candidate for a lot of engineering applications. But a stronger force than that is the public will. So when the public will reaches a certain tipping point, I think we will see a lot more use of high performance materials which are less susceptible to corrosion.
It's going to revolutionize the bridge rail industry across the world.
Ultimately, it's not what I say, it's how it performs. And in the case of FRP, it proved out the design works.
I just don't think that anybody believed that they could create a combination of steel and FRP to withstand the impact of automobiles in a bridge rail environment. Ames was the first to believe that it could happen and to actually manifest that belief into a product that worked.
And for the public, you've got a safer product.